So currently we're working on a Hort Innovation funded project, which is a national project focusing on the adoption of precision agriculture in Australian vegetable systems. So the first and I guess key objective for growers is to determine whether or not they have variability on their farm and how it's actually affecting their crop and their yield. And there are different methods to do that, such as crop sensing, EM38 and yield mapping as well. I guess what we like to encourage growers to do when they do get this visual information, such as a spatial variability map, whether it be crop sensing or EM38, is to go out and actually ground truth the image. So do site-specific sampling in the field so they get a good representation of what the variability is doing to their crop in terms of yield and quality, and what is actually driving that variability.
So in the mallee landscape, we have a strong dune swale system. So we typically get very deep sand dunes, and then in between we have this sort of heavier ground, which we know can cause substantial variability in our crop production. And so what we started with was a really good soil survey. So we actually mapped a number of soil chemical properties, pH and the basic nutrients across the site in the mallee. And then we've used a number of in-crop measurements, I guess, actually using a plane. So we've measured NDVI and chlorophyll, so an indication of nitrogen in the plant, and also thermal properties as well, so soil and canopy temperature, and then as an indication of water stress. We've found that the relationship to soil type is really strong. So where we do have these deep sands, we know that generally the crops can struggle to get away. They don't generally establish as fast, and then I guess then you get a delay and a change in the maturity of a crop across a pivot. So where the carrots continue to be green right up until harvest, we know that potatoes senesce, they naturally die off as they mature. So the types of imagery that are applicable in potatoes, I think, are going to be different to a crop that's still green above the ground when it's harvested. So I guess it's going to be a bit more tricky trying to relate below ground tuber biomass to what we can see from above. And at the moment, it appears that the thermal properties and the water stress images are actually giving me a pretty good indication of, I think, the relationship between above ground and below ground biomass. I guess that what it confirms is that in our dune swale systems, that things like irrigation practice and variable rate irrigation as a start is going to be quite important in managing yield variability, because we know that the productive potential of the sands versus the heavier swales is different. Also our nutrient inputs, we could look at variable rate nutrient inputs. The next big step from there is actually assessing, well, what's it costing me and how much can I actually afford to invest to perhaps change the soil type. So we've already got adoption of clay spreading on our sandy soils. So how can we optimise clay spreading, the addition of organic matter, and overcoming some of the physical and the chemical constraints that we know exist in our deeper sands, so that we limit, I guess, degradation of the heavier swales in between, because we know they can get quite waterlogged from the water that comes through the sands, and so that we can really optimise productivity across our whole pivots or whole paddocks.